Now it's time for our next presenter. He's Philipp Hesse, and a German architect based in Denmark, and working with, may I call it, international architectural heritage, yes? Also a board member of Denmark ICOMOS. And his presentation is on titled FuturHist, Tailored Intervention Solutions for Future-Proofing Historic Buildings in Europe. The floor is yours.
Thank you so much. I will just share my screen and then we can start. Yes, thanks a lot for having me. I would like to present today for you the FuturHist project, which we are working since January 2024. Together, it's led by the Europe Research Center, and ICOMOS is one of the consortium's partners. It's a European founded project from the European Union. And the question we started with was like, every historic building is different to some extent. It's like a row housing in Scotland, or of course, some Alpine architecture we have in the project. And the question we were looking at is like, what if we could develop retrofit solutions for the historic buildings, and that we can standardize sometimes the question we all are working with. And it was like to shift the focus from the individual buildings we have all over in Europe, more to try to find building typologies which are always the same and presenting, in our case, more than 10% of the building mass in each country, which from the demo sites where I'm coming later to get the idea to get solutions which are also usable for that. So what do we want to achieve in the next 4 years? We want to improve the planning process for the retrofit of the historical buildings towards more standardized approach. We want to develop innovative solutions for an efficient energy and resources, and of course also for healthy and durable built heritage. And there we are not looking just on listed buildings, so it's all the historic building mass in the countries we are looking on, and to contribute towards the decarbonization of historical buildings with the development of strategies for heating, ventilation, and cooling, of course, depending to the different sites we are working on, and to facilitate the adoption of optimized packages for solutions with the buildings and with other, to integrate the decision support system, and of course to scale up the energy retrofit of historical building houses through our demonstration sites we are working with, and the replication of the topology-based approach that we can also say that can be scaled up later to be used. FuturHist is a consortium from different partners, and at all it's 17 partners. You can see on the map which countries are part of the consortium, and Italy is marked in the darkest because Europe is the lead of the project, and the research center is sitting in Italy. The whole title and also some key figures, like as we already heard, it's an integrated typology-based approach to guide the future development of the European historical buildings towards a clean energy transition. It's founded by the European Union, and we are now like in the end of the first year. We have 17 partners working on the consortium, and ICOMOS is one of the partners. We have one associated partner, that is Church of Sweden. 8 countries are included in the project as from the partners, and we have 4 demo case countries where we are working with. We would like to develop solutions and tools, of course, for more natural isolation materials for historical houses, the window retrofit, and of course, it's the biggest one, the decision support toolkit, which also should help to standardize the work with that type of buildings. with the natural insulation materials, we would like to develop what material, like bring more clear solutions for the materials for emphasizing energy efficiency, durability, and conservation compatibility, and of course a strong focus on circularity and waste reduction in the process to use these materials in the buildings. And the 4 solutions we are looking closer on is like a prefabricated line-based insulation panels, self-healing interior plaster, prefabricated panels, and another insulation plaster which is used in different of our demo sites, which I'll present a bit later. The retrofit, because there's this long discussion to change always the windows, especially in the Nordic countries, it's still quite that it's easier to change old windows. And there's the ambition to preserve the diversity of the historic windows we have in all over Europe while promoting the durability of these already existing windows, and of course reduce the environmental impact. And we will develop new solutions for the retrofit of historic windows to ensure that the conservation of the existing is possible, and also the improvement, of course, of the performance, but fitting for the historical building mass. And we will test existing and retrofitted windows in the UREC research laboratories, so that we also can get information about the energy performance improvement, which we wouldn't have time to do so in the demo case sites. And then, of course, that's also a big thing, like how to analyze the existing commercial technologies and conventional use to cover the thermal needs for historic buildings. And we would like to, or we try to achieve, to move forward to identify baseline practices and highlight related energy and environmental performances. And FuturHist will also develop guidelines for the adoption and implementation of renewable energy sources in historical buildings to our demo case countries. And then, of course, a decision-making toolkit, because at the moment there's several tools for the question already available and quantified about potential energy savings and improved comfort. The problem we found out so far is like a lot of them require complex time and consumption simulations, and often leading to that they are not really used in the practice or used by practitioners. And we would like to gather the information and tools from previous research projects and combine these with the new developed solutions into a simplified tool build tailored to our typologies we considered in our project. And of course, considering the aspects like climate, construction materials, and heritage significance to help users to find an optimized holistic renovation concept. We have 4 demo case countries where, or like demo case sites where we are working with. The one is also to try to map the different climates in Europe. So one is in Cordoba in Spain. Then we have Krakow in Poland, Linköping in Sweden, and Edinburgh in Scotland. Cordoba is like, of course, from the climate area, it's southern Europe, so we have hot summers and cooler winters. The building we are working with is from 1683, and it's a load-bearing masonry of solid brick and wooden roofing, which was already renovated some years ago, and now it needs another renovation. It's an internal, it would be nice to improve that building with internal isolation of the historic facade to improve the thermal performance, while of course also contributing to a healthier indoor environment. The housing of the complex at the moment is an apartment complex from the first floor onwards, but doesn't have any heating systems. But the winters can still get quite chilly in Cordoba. The balcony doors and the facades will be maintained and restored. And of course, we try to, the goal is to improve the losses in the winter, and also the upheats and the heat in the summer coming into the solar gains, especially the apartments under the roof have a big problem of heat in the summer, and it should be like an efficient solution for heating, cooling, compatible with the architecture, and also the social containers of the building will be installed, because most of these buildings, it's a big square in Cordoba where it's all around, is social housing. In Krakow, we have a semi-continental climate with more cold winters and more mild summers. The building here is from the first half of the 19th century and was modernized in the end of the 19th century. It's a brick building with timber roof covered with metal sheets. And here we also work with the demo case works with the isolation of the building envelope, the introduction of traditional clay isolation of the foundation walls, and the installation of a mechanical ventilation with heat recovery, and with a PV installation on the southern roof slope of the roof. In Linköping, it's building from the Church of Sweden. Of course, we have a cold and more humid continental climate there. And the main, in the east part of the building, which we are seeing in the picture, was built in 1830, the west part, and the round extension followed later up until 1926. It's also brick construction with wooden joints. And here the focus will be a smart control of the heating and ventilation system for the use of the building, and the renovation of the windows, because the building has really a lot of traditional or still original windows inside. And the last demo case we have is Edinburgh, where it's in 18th century houses, and there's a test of an innovating self-healing and isolating lime render in the project, because the facades are of course protected, and also as a part of the World Heritage Site, and also the windows will be changed or will be improved. The project we have, like FuturHist, is developed in 7 work packages. Now I will just go through them a bit, and please be aware they are not in the same row. It's like not number 1 to 7. It's just because now we are going through them, which are already started. The first one, which we are in the end, because it's going until month 12, so December this year, is drawing the baseline, which is led by the Uppsala University. And there's 6 tasks we are working on, and ICOMOS is a lead partner for that, for the identification of barriers. There we just finished a survey through whole Europe about the barriers, which are now mapped and writing the deliverable. And there's also like interviews for the demo case countries to improve, like to get more in the details of the survey, to get information what is required, what is like the main barriers for the project. And we can see that there's, for the different regions, also different barriers. Then of course the task 1.2, we are doing an analysis for the building stock and defining the topologies we are working with, and looking into policy, and also analyzing the existing guidelines and tools. And of course also the current practice of energy retrofit. The work package 4, which is already started, is the developing of an integrated planning tool. It's led by the Danish architecture company Erik Architecture, where we also try to test already tools for the solutions we will develop in work package 2 and 3. And of course, the base is also the work package 1, the barriers of that. Then we will in work package 2, which starts, which is partly started, but it goes on until month 30. We're looking on the passive solutions for energy retrofit. And then in work package 3, we will work for the activate systems for clean energy transitions. And in work package 5, work package 5 consists mostly the demo case which I just showed, where we will be practical work on the projects which are partly already started. But then the main works will happen in the month 19 to 48. And the work package 6, we would like to scale everything up, that we then also can use it and share it with the knowledge transfer, and especially the policymakers, that we also can share it with all other countries in Europe. And the work package 7 is, of course, the dissemination, communication, and also sharing the information. And the summer school, which will be held by ICOMOS in different demo case countries to also train the next generation of the for the retrofit of historical houses. And then, of course, work package 8 is all the management of the fight and the organization of the project. If you would like to know more about Future Version, I know it was quite a short and quite a fast introduction to the project. You're more than welcome to join our newsletter, also visit our homepage to get more information about that. And thank you for your time. And I would like, and if there's any questions, I would like to answer them. And you can see also again our project partners, which are all from practitioners up to policymakers. Thank you so much.
Thank you, Philipp. It was very interesting to hear about, and I'm sure there are no questions among people here. So I have an introductory question, maybe, until other questions are formulated. Would you elaborate exactly how far is your project at the moment? What is the moment that you're working with yourself?
From our ICOMOS side, where I'm working, so I'm working on the project actively from ICOMOS international side out. So we just finished our survey, and we've got more than 150 answers from 27 countries in Europe, which we all analyzed and now writing together and put like it really framed out that there's a different climate regions which we have in our demo cases, that they also have completely other problems or like other barriers they see. And we started with the interviews resulting on the answers we got from the survey and writing the delivery review, and we will send that in the like we will finish that in December that year. And then, of course, we are already working on the work package 4, so that that team which is working there also can start and has already the informations from the ICOMOS work to make, like, we are drawing the baseline now at the moment, to then the other work packages can use that information and work on them.
Thank you. So, questions? So, thank you, Philipp, for your time and for the introduction of this interesting project. I'm sure that more people will take interest in that.